Hi everyone, welcome to Lisp DNA course. This course I designed only because I'm preparing course for DNA, and in DNA I can't put everything related to Lisp because Lisp is again one topic that you can use independently inside your infrastructure. And so many companies at the moment they are using Lisp feature. You can think Lisp as a overlay feature as well, and inside DNA it is used as a control plane or a routing plane engine for the digital network architecture. So what are the topics I'm going to cover, like starting with Lisp introduction, how it works, what is the use case. One of the very important topic is packet walk, then the configuration. So I have taken two examples of configuration, like basic configuration and configuration in terms of virtualization when you are creating some VRF. So at that time how we can do the configuration verification, and finally we have Lisp features related to catalyst switch. So I hope this particular course will be informative and enjoyable for you. Hope I'll see you in the course. Hi everyone, welcome to our DNA Digital Network Architecture Lisp course. Lisp is again Locator ID separation protocol. What is the reason I created this course? Because I am preparing course for DNA, and inside DNA we have so many different things. So inside DNA we have something called policy plane. For policy plane you need to learn, understand ICE. You have control plane. Control, you can refer control as a routing. So for control plane, you need to learn Lisp because inside DNA, they are using Lisp as a control plane. And obviously you have then data plane as well. Data planes, we have different endpoints. You need to learn WLC as well because WLC controller is also a part of DNA architecture. Apart from that, you need to learn the Epic EM controller. Okay, so that's why that particular course become very lengthy, and I don't want to make that course, this DNA course, that lengthy. So that's why I created a separate course for Lisp. Okay, so we'll understand Lisp here, although in the DNA course as well I have covered Lisp. So if you know, you can skip, otherwise you can go through it. Okay, so let's just check. Lisp is an old technology from Cisco, and why they have created Lisp, obviously we'll discuss. In this particular Lisp course, I'm going to discuss about the Lisp architecture. Then I will cover the Lisp use cases, what type of use cases we have. Then how we can implement. I'll show you a small lab related to Lisp that you can do over GNS or Viral. I'm going to use Viral for that lab. You can do the configuration. I'll show you very small configuration, but you need to understand what is the Lisp architecture, what is the terminologies behind Lisp, because everything is new here. If you don't know this protocol, you'll find it quite new, related to some other technologies or protocols we have. And then the Lisp feature interaction. We'll see all these things one by one. Now, when we are talking about Lisp architecture, first of all, why we need Lisp for the campus architecture? Why we need? Because we have some requirement. We want, how do I better aggregate the routes in my network? You want better route aggregation. Then what is the other requirement? How do I assign IP address independent of topology or location? We'll see that. This is quite an interesting thing here. And I'll show you in the upcoming slides that this requirement is actually the basic, or actually the need that we are creating Lisp, that you want independent of topology and location. So IP address, you can break IP address in terms of topology or location. We'll see that in the upcoming slide, how we can achieve that target. Then We have ease of manageability, means how can I easily migrate subnets and scale my network. We'll see that as well. And finally, the fourth point is how can I employ flexible in end host addressing, that is, it is address family independent. Okay, so you have flexible IP addressing, ease of manageability, optimal routing, everything, all goals you can reach with Lisp. Alright, so let me show you here in the diagram how we can achieve that target, and then one by one I'll show you all the terminologies. So a few of the terminologies may be very new to you. So here you can see my campus area network wants to communicate with site 1, 2, 3. These are my A's. Say I have autonomous system 100, 200 and 300. Now from my say head office or branch office to other site, how I can reach to the other side. So I have two options. Either I can use NAT, or I can create some sort of tunnel from this location to my remote location. Correct? So maybe GRE, MPLS, IPsec, these type of tunnels I can use. Correct? Now, what is needed in locator ID separation on a global scope, and that doesn't carry all routing in the forwarding plane. Again, I'll tell you that what does it mean, that you don't need to have complete routing table per router or per device. You need only the host routing table, and plus you need some mapping system. We'll see that how it will do. But what is the use case here? So use case here is, let put ID addresses and locator addresses in different database. Let's create a level of indirection between ID and location. Okay, so location and ID we can have in two separate database that will be inside a Lisp mapping system. I'll discuss that as well. Then you can achieve that target. Now from this diagram, let's understand what I try to explain. So why we need Lisp? Because we need some separation between our plane. So what are planes I have? I have say topology routes. I have, let me just show you here so you can see it better. Endpoint routes. Let me highlight as well from my marker. So here you can see that I have topology routes, I have endpoint routes. Now, before the use of Lisp, IP address equal to identity plus location, you can see that all my devices, they have the topology route plus endpoint routes. Correct? So the endpoint routes here is in blue. So what we can do, that we can separate the endpoint routes, and this topology route, whatever topology route I have, I can save inside server. Okay, then suppose if my endpoint wants to communicate, then whether it wants to go, it will try and query. So it will try and query, or it will try and resolve that destination to the mapping server or mapping database, and from mapping database it will come to know that how he has to go. Okay, so this way, if you do this particular methodology, that is the Lisp, in this way you can reduce the size of routing table. That means your CPU process cycle will be reduced, because all this routing information have to be processed via CPU. That is the first thing, because initially you have big tables and more CPU with local L3 gateway. Now what you are doing, that you are reducing the size of the local routing table, so that's why you're reducing the CPU first thing, plus you are using the anycast 1 to nearest L3 gateway. Okay, so this is very efficient way to do the routing, and in terms of DNA, this is the DNA control plane. Okay, now let us learn more about this. We're going to learn more about this, means how this mapping is happening, what is endpoint to ID mapping, all these things we'll learn. But before that, what my end host is doing, that it is going and querying like a DNS. So okay, this IP I want to resolve. So here you can see that where is, say for example, MAC address. So where is this MAC address? Lisp map system is telling, okay, these are the IP addresses, have this MAC address. They are doing something, say ID to locator map resolution, but I'll explain more on this. Let's understand some of the terminologies first, and then we will learn and understand the mapping system, how this mapping system or mapping resolution happens. So here in the diagram you can see that we have three definitions for the Lisp, and in the DNA also you will understand these things as well. So if I draw here, in DNA you'll come to know that you have edge node, you have border node, and you have control plane. So edge node devices you have, border node devices you have, and you have control plane. Control, for the moment, control, you think control as a routing. So you have routing plane. Okay. Now, endpoint identifier, that is the EID, is the IP address of the host. So here I am getting the IP address of the host. Then I have routing locator, is the IP address of the Lisp router for that host. Then I have you can see here the endpoint space I have a router locator. Here is my, say, control plane or routing plane. So we have some namespace. You can say that we have endpoint namespace, we have router namespace, and finally we have endpoint to router locator mapping, is a distributed architecture that map endpoint and router locator. Okay, so here you have endpoint, here you have router locator, and here you can see that if I am reaching up to this point, that means I am reaching to this point. Alright, no problem. I'll again explain this. So what we have done so far, that we have divided the, say, host route and the topology route. Host route is local to the endpoint. So you can think like this. Let me again explain here. So this time it will be very much clear. So I have this type of fabric. I have, say, end node where I have topology route before Lisp implementation. So I am learning the topology route, I am learning the local routes like host route. Now this particular topology route, this will be mapped, or this will be stored to the mapping system, mapping resolver. We'll see that in the next slide. So now it is building all the or you can say that it is offloading all the topology routes here. Now suppose if my host has to go somewhere, it will go first, it will query. Okay, so where it will query? It will query to the control plane that, okay, for this particular destination, how I can go, correct? And at that time it can use endpoint identifier to routing locator. Okay, so you have three things. You have endpoint to routing locator, and then you have routing locators, correct? So this is the host IP, is the IP address of the Lisp router for the host, and this is the mapping. Now if you do all these things, then it will give you network based solution, no host change, minimum configuration, no DNS change, address family agnostic, incrementally deployed, because you have separate control plane. So your host can move, and because you are using Anycast gateway as well, so host can move without knowing that they need to change their default gateway. Okay, so you can give some mobility to your clients as well. Now here you can see some other terms as well, like PXTR or TR. Okay, so TR is nothing but tunnel router. PXTR is nothing but the proxy tunnel router. So suppose if you are getting some packets from non-Lisp space, at that time you can use proxy tunnel router to incap decap, and you can send to the e-nodes, or you can send to the destination. Likewise, here the incap and decap is happening. So what is this incap? What is this decap? I will explain in the next slide. So let us go to the next slide where we have these terminologies: incap, decap, and TR and PTR. So here you have. Here you can see that you have three namespace: endpoint identifier, namespace 1, router space, that is the namespace 2. Then you have you should have endpoint to router mapping. It is not there in this diagram, but anyways, apart from that, you can see that map server resolver. I'll explain in the next slide. EID to RLOC mapping can be distributed across multiple Lisp devices. Now, tunnel router, we have two types of tunnel router. One is tunnel router, one is proxy tunnel router. Proxy tunnel means if you are getting subnets from non-Lisp environment. Okay, and here you can say the ingress egress tunnel routers. So for ingress egress, you can use IE, TR, or PTR. We'll see that in the next slide. So for both the proxy or tunnel routers, we have ingress and egress direction. What does it mean? How it will fit into the picture? So let me show you that as well in the next slide. Just a minute. Let me go to the next slide. Okay. So here you can see that in this particular diagram, it's a very important diagram. I have some subnets. It is going from one place to other place, correct? Now, you can see that I have tunnel router 1, tunnel router 2, tunnel router 3, tunnel router 4. Inside tunnel router, I have egress tunnel and ingress tunnel. Egress tunnel, ingress tunnel, correct? So now, if I have to send packet, how I can send? First of all, the ingress tunnel routers. What is the use of the ingress tunnel router? It will receive the packet from the site facing interface. So it is receiving packet from here. Incap, it will do the encapsulation to remote Lisp site or net. If it is not a Lisp site, then it will simply forward the packet, but it is a Lisp site. It will encap the packet. It will encap the packet and then it will send. No problem on that. Now, what is the role of ETR then? ETR, it is something like egress tunnel router. It will receive that encap packet and obviously it will remove that encapsulation, means it will do the decapsulation and deliver to the other end, correct? So from one side you are getting the packet and you are delivering to the other side. There is no problem on that. So you can see that. Let me go back just a minute. Yep. So here you can see that I am doing the encapsulation and I am doing the decapsulation, encapsulation at the level of ingress tunnel router, decapsulation at the level of egress tunnel router. Now, where is the mapping system comes into the picture? Where is my database comes into the picture? Now here I have the database. Now here you can see that I have map server, map resolver. Now what is the use of map server and map resolver? First of all, you can see here the use of map server in the egress direction, that is the ETR, correct? So Lisp side ETR register their EID prefix here. We'll see that configuration in the lab. Don't worry about the configuration. So requires Lisp side policy authentication key. Receive map request via map system. So map request via map system. But whenever we are talking about MS, think about egress tunnel router. Now what is the next? Next is MR, that is the map resolver. What map resolver is doing? Receive map request from ITR. So once the packet is coming, suppose it is a Lisp oriented packet, it will send a request. Okay, so you can see the receive map request, it will send request and it will forward to MR. Correct? It is forwarding to MR. Now what MR is doing, that MR forward map request to map system. MR is forwarding that request to map system. Send negative map replies in response to non-Lisp. If it is a native packet, obviously it will forward to non-Lisp. It is a Lisp related packet, it will forward to the mapping system, obviously for the first time. And as a whole I am telling this as a mapping system, but inside mapping system it will forward this to MR. MR again, just to do the resolution, it will forward that packet to MS and then it will go to the ATR. Correct? Obviously this is happening in the normal say switches or routers as well. So suppose whenever you are building your routing table, if new packet arrives, then you are not checking your safe entry. First of all, it will be going towards CPU. Once it resolves that what is the next hop, then next time maybe it will go via line card or line rate. Okay, so first time if a packet is coming, it don't know how to go to the next hop. It will get resolved here in the MS, that is the mapping system, and then it will forward to the egress from the ingress. Okay, so these are the terms. Now we can see here that how many terms we have. So we have discussed a lot many terms related to Lisp, and I have explained that why it is very important to offload the topology and the endpoint routes, means you can decouple the routes. Simply we can tell. So local routes, I am decoupling with the topology routes. For topology routes, I have better managed server in my infrastructure where I can manage all those things inside the database. So if I have any query, I can go there, resolve my destination, and then I can go to the next hop or the destination. All right, let's stop here. In this session, I'm going to cover Lisp use cases and implementation. What use cases we have in Lisp? You can do Lisp multi-homing, redundancy, load balancing, and ingress traffic engineering. What is the need? That site connectivity to multiple providers, it will provide you low operational expense and the capital expense, that is the OPX and CapEx. What's the solution? If we are using Lisp, then it will provide a streamlined solution for handling multiple provider connectivity and policy without BGP complexity. Because again in BGP you need to give some BGP best path attribute or best path selections where you can prefer say ISP1 versus 2, etc. What are the benefits we have? We can have multi-homing across different providers, simple policy management, ingress traffic engineering. So these things we have if we are using Lisp, and because we are telling all the time that with respect to DNA, Lisp is used as a control plane, or control you can refer as a routing plane as well. So routing things will be very simplified if we are using Lisp. That is one use case. The other use case that for IPv6 transition. So if we are using Lisp, you can see that it is going towards IPv6 cloud and then public IPv4 cloud. Let me show you the animation as well. So public internet enterprise, I can reach to the endpoint identity groups because I have the locators and the database separated somewhere. So it can easily use IPv6 transport as well. Okay, that is one other use case of the Lisp. So here you can see that I have proxy routers, I have map server resolvers, and it is resolving the IPv6 internet web presences. That is the other use case. What are the other use case? What is the third use case we have? Now here you can see that I can cross the boundary from IPv6. I can go to IPv4 and then again I can go to IPv6. Again, here the encapsulation and decapsulation will happen. So how it is? The source is IPv6, destination is again IPv6, but in between my encapsulation and decapsulation happening. So at the tunneled router, I am doing the encapsulation, and again here I am doing the decapsulation. Here you can see the encap, decap is happening, and the source is IPv6, destination is IPv6. Okay. So no disruption of existing WAN connectivity. IPv4, IPv6 use same infrastructure and protocols. Lisp can transport IPv4 over IPv4, IPv6 over IPv4, IPv6 over IPv6, and IPv4. So 4 to 4, 4 to 6, 6 to 4, and 6 to 6. So all these four combinations are there when we are using the Lisp. It can support virtualization as well in case of multi-tenancy environment. Now all these things are leading towards SD software-defined access. So in software-defined access, we need optimal routing or intelligent routing. We need multi-tenancy environment. We need IPv6 infrastructure as well. So this is also possible. What we have to do here, you can see that I have either tunnel router or proxy tunnel router. I am using instances and then IP and the locations. I can map those locations and I can create multiple instances of various uh, instance IDs. Okay, so Lisp solution is that you use instance ID to color mapping, control traffic and data traffic, mapping database and Lisp cache for tunnel router is instance aware. On TX, tunnel router use VRF. Obviously, if we are using VRF, then we can divide a global routing table inside, say, customized VRF tables, and in that way we can create network virtualization inside the Lisp infrastructure. Okay, so these are the use cases. Now, how we can implement it? Again, in the DNA course, I have given a complete list of devices for control plane. Here I am using example of say 6K platform. So just if you have 6K platform, how you can implement it. In 6900, I need supervisor 2T card and image will be 15.1.1sy1 software. Now, what are the supports we have? Obviously, you can always refer the dataset. Okay, and even you can refer the DNA data sheet. So there you will come to know that in control plane, what types of devices we have. We have n number of devices supported in the Lisp infrastructure, not only in the Lisp, but in DNA infrastructure as well. You can cross verify. Now, if you are using 6K platform, say 6900, you have ingress, egress, tunnel router, proxy, ingress, egress, tunnel routers, map server, map resolvers. These are the functions of Lisp that we have already discussed. What are the Lisp features? We can do IPv6 translation, multi-homing, shared virtualization, just now we have discussed. So these things are possible in 6900. If we are referring particular line card like PFC, so in PFC, featuring improved level of performance and scalability, along with new enhanced hardware feature. Obviously, we have hardware support for all these functions, and Lisp is available above, starting from say 15.1.1sy1, and it is there in 6500, 6800, even 6900 line card required for in-cap, decap purposes. If you have integrated chassis like 6880X, and future generation line card like 6500, 6807. So yeah, you need to refer the hardware. What hardware is supporting, what is not supporting, whenever you are planning to design the campus area network. Now Lisp encapsulation and decapsulation. So what is the limitation? Lisp encap not supported natively in the URL. URL is a ASIC inside the 6K platform. Even I think in Nexus also the URL is used, but you can verify URL 8 may be used inside Nexus. But it's a ASIC, it's pure hardware type of things that I am showing you from last 2-3 slides. Now, fabric and replication ASIC, port ASIC, result is generated by DFC request for lookup instead. We have FPGA just to resolve the request of Lisp. So FPGA only present in 6900 series line cards. We can add functionality to this FPGA and implement any new rewrites. FPGA needs to be on ingress line card for Lisp encap decap. By intercepting the result, we could do many things to header and recirculate for additional processing. Having a flexible FPGA at appropriate points will help its platform features. Simply just refer the hardware. Okay, and then finally you can see if we have this modular chassis, how the topology look like. So you have 6904/6908 any line card. Obviously you have supervisor engines in your chassis. Then for the ingress line card, does the encapsulation, so packet is moving from your site, you are doing encapsulation here and it is going. Likewise, whenever package is receiving, you are doing decap here and it is received towards the site, it is originated from the site. So those things are there at the level of line cards. So let me stop here, and in next section I will show you that how the packet walks happen inside the Lisp infrastructure. Anyways, if you are very good in the Catalyst platform, if you know the hardware and all the line card and the module, then this particular slide is a reference for you. So here you can see that in this layer 3, layer 4 forwarding engine, and there are so many things inside this as well. So we have layer 2 forwarding, we have layer 3 forwarding, and then there are recirculations. So here what you can see that, okay, fibcam, and in the side by side you can see that we have CIF entries pushed to fib under VPN ID. We have Lisp 0 adjacency, ACL to match endpoint entities noted for COP. By default, there will be COP policy, control plane policing. Then, so this is in the ingress direction, this is in the egress direction, netflow cache statics egress, logical interface used to do the source interface lookup, and EID. So very much that we have inside 6500, but when we are adding the features and when we are adding 1511 image, at that time how they will do the Lisp lookup, so you can see here. Okay, so I'm going to stop here, and in the next section we'll discuss about the Lisp packet walks. In this section I'm going to explain the Lisp packet walk. Now here you can see that we have inner IPv4 header for endpoint IDs. We have Lisp header, UDP header. For that the destination port is 4341. Then we have outer ITR supplies RLOC header. So we have inner header, we have encapsulation, we have outer header. The overall the payload, you can say that for the header is 36 byte for IPv4 and 56 byte for IPv6. Now you'll find this section very interesting, how this encapsulation decapsulation happens. Let's see the packet walk. Now, in case of data plane, where my source is here, my destination is here, source is 10101, destination is 2201, my router locators are these. Let's see the flow. So in this case, suppose my source and destination, I want to reach from site A to site B. This is my destination, this is my source, this is my destination. How the mapping happens. So here you can see all our mapping. This is my internal IP header, LISP header, UDP destination port, and then the source and destination for the outer IP header. Correct? So what this device is doing, that it is doing encapsulation and it is sending the packet. Correct? Now when the packet will reach to this particular site, that is site 2, it will be decapsulated and it will go to the site number 2. Easy? Correct? So now we can understand that in the data plane, what is the use of this locators. We have locators 111, 2111, 111 locating this, 2111 locating this, and this is the flow of the data plane. This is one of the case. Now let's see the other. In case of IPv6, because already we have discussed about Lisp that this is address independent. So irrespective of IPv4, IPv6, they can easily do the R location or router locations. And here, instead of IPv4 address, you can see now they are adding the say here we have IPv6 address. Now it is adding the IPv4 headers and it is going along. So source is IPv6, destination is IPv6, but in between we have IPv4 encapsulation, decapsulation happening. So very much similar to the unicast IPv4 data plane. Only the address scheme is different. Now the other advantage we have with Lisp is multi-homing. So multi-homing data plane forwarding, how it will be. Here you can see that I have site 1 with 2 hosts, host A and C, site B with 2 hosts, say host B and D. So here I have AC, here I have BD, but inside site B I have 2 link. Correct? Because this is a multi-homing type of infrastructure. So that's why I have 2 locator. One is 2111, other one is 2121. So this is my locator for site 1, this is my locator for site B with respect to data plane. Now how the data will move. So obviously my endpoint entries, they are mapping with the locator. In the destination also you can see they are mapping with the locators. Now see the data flow. My map cache 102024, the locator 211 and 2121, priority and wait. It's okay. Now when the packet will start moving, so my source is 10101, destination is 10201, source is .2, destination is .2. Let's see that how encapsulation decapsulation happens. So for source number 1, this is source, this is destination. This is my outer header. For other request, this is my outer header. So here you can see your outer header is different. So one time you are using this header, other time you are using this header, and you are doing the multi-homing. Even you can say the load balancing as well that we have discussed earlier. Correct? So this way they will do the data forwarding in case of multi-homing. Now when we are talking about multi-tenancy, for that, in this particular header, what you will find, you have instance ID here. When network need to be virtualized, instance ID can be transported in the Lisp header. 802.1q VLAN tag or VPN identifier could be used we have 24-bit instance ID marked as I. Where it is? So it will be here. Correct. Now let's see the data packet forwarding. In case of virtualization, same infrastructure, same network. Now we are moving from VRF to VRF. So here my source address is in VRF1. My destination address is also other side VRF1. Now here you will find one new 64-bit that will be instance ID. Okay. Rest all those things are the same, and we are moving from VRF to VRF. Correct? Now let us move to the other criteria. So suppose if the traffic is moving from LISP to non-LISP IPv4. Okay, so whenever we are talking about non-LISP, then at that time you have proxy node, and we are using PXT R here, X maybe ingress or egress. So that's why we have X. Okay. All right. So let's see how the packet move will happen. So your packet will start. We have the mapping database for 10.1. The locator is 111. This is the source. This is the destination. Now what will happen, because you are going towards non-LISP, so once the packet reaches here, the map request for 2111 negative, map reply forward to native. So you will get reply that you have negative reply for this. That means you have to forward it natively, because this is the non-LISP destination. Okay. And suppose for the return traffic, suppose if you are okay, let's complete this animation like that. It is going natively. Now suppose if you are coming from non-LISP site to LISP site, so at that time how the packet flow. So here you can see that mapping database for this. Now XTR replaced with PXTR. This is my proxy. PXTR need to be inline. So here you can see. Now we have the LISP outer headers, because now I am moving towards the LISP infrastructure, and then it will go like this. Okay, so both way we have traffic. Either we are moving from LISP to non-LISP, so it will forward to the native destination, or we are moving from non-LISP to LISP, so we have the outer header, we have the UDP port and LISP header, and then it will forward. Now let us quickly discuss about the control plane data forwarding. So far we have discussed about the data plane. Now how this control plane registration happens. Okay, so this thing we know that, okay, I have site ID or host pool. You'll come to know this thing inside DNA. DNA, they are marking this as a host pool, or you can say that endpoint entities EID. So anyways, your prefixes, they are coming from the site ID. It is going to egress tunnel router. Now here for my MS and AMR, this is the mapping IP. Let me clean. Now what is happening? Let's see. So the ETR register with EID prefix with the map server. How it is happening? So with the mapping server, it is going to the map server here, and how it is mapping. So my 111 is mapping to 5111. My 2111 of this side is mapping to 5111. Like that they are mapping here in the control plane. Okay, so this is the request. This is the request that is coming from egress tunnel router. Now we'll see that how the reply comes into the picture. Reply. Control plane map request and reply. Let's see. Now we have the ITR here. Now we have the ITR here. This side ITR, this side ETR. Let's see the flow. So I'll go and go next. Yeah. So you have your source, you have destination. Now this ITR, it is asking, how do I get 10201? That is the destination. It will query to the MR. That will be the map request. Now here in that database, 111 is mapped to 5111, correct? And 1111 has a destination of 10201. That's correct. Now here in the ETR, the 5111 is also mapped with 2111. Okay, this is the Lisp map request. So here you can see everything is in the form of request, correct? Now the reply. So because these things are mapped with 51, this is mapped with 511, this is also mapped with 511, that means 111 has to go to 2111, and in the reply, yes, 211 is coming back to 111, and here you can see the reply packet has UDP port number 4342. The request is also that is going towards the controller or the control plane is 4342. But we have checked this inside the data header. It was 4341. Okay, so remember your packet capturing that you are going towards the data plane or packet capturing going towards the control plane, you can identify with the UDP port numbers. So this was the packet capture or packet walk, you can say, that we have done with respect to all the features actually. IPv4 to IPv4, non-Lisp to Lisp, Lisp to non-Lisp, IPv4, IPv6 to IPv6. Plus we have checked the virtualization as well, that is the multi-tenancy packet walk as well, and finally we have checked the packet walk towards the control plane as well. So that's why this will become very important. Say if you want to understand Lisp, if you understand all these packet walks and all the terminologies, means what is the tunnel router, what is the proxy tunnel routers, what is the router locators, what is the endpoint identities, then it will become very easy for you to understand the Lisp concept fully. Alright, let's stop here. Let us do the Lisp configuration. Let me show you the topology that we have. Here you can see that I have topology where I have, say, switch 1 in this side, switch 2 in this side, and in between switch I have this core network. Here you can see that router locator is 111, router locator is 222. So in my lab, instead of this switch, I'm going to use routers, and the lab I'm going to perform is over VRL. Okay, so what is the configuration for the XTR, either the ITR or ETR? It's very much similar that we are doing for any routing protocol. We're going inside router, say Lisp. You can give, okay, endpoint identification table default instance ID 0. If you're not giving this, by default it will take instance ID 0. Then database mapping. This is my site prefix. I'm mapping this to the router locator, that is 111. Priority and weight we can give. Then my ITR configuration. So ITR is mapped to map resolver here in MSMR, that is 5111. Then IPv4 ITR, likewise. My ETR is going towards map server, the same address, and then I am giving the key as a site 1. Alright, then IPv4 ETR. So this is the complete configuration here we have for XTR with respect to ITR and ETR, and then finally default route pointing towards the gateway. Okay, so if you do this baseline configuration from one site, and the same configuration you can do to the other side. Only thing that your subnets will change, your router locator IP will change. So here subnet will become 2, the locator will become 2.111, rest everything will be same, and the IP route will be changed. So let me show you that as well. Here you can see. So we have all those things, and instead of 1, it become 2. Now finally, we have the configuration for the MSMR. In MSMR, again, it's a very simple configuration. Mapping can be within an instance ID with the maps to a VRF. So let's see. Now router list for site 1, I'm authenticating with end EID prefix, that is 10100. The other site, I am authenticating with site 2 key 10200, and this particular server is my IPv4 map server, map resolver. That's it. So that's all the configuration. Then we'll do the verification. Now in my particular lab, what I am doing, I have routers. Here also I will take router in this point. Here also I will take router, and this 51111 I'll make as a loopback, and here I can run say BGP as a protocol. Okay, so let me show my viral diagram. Let me show you that, and then I will do all these configurations, and then finally we'll verify as well. So from Lisp 1, I'll send packet towards Lisp site 2, and then we'll check the reachability. Okay. So here you can see my Lisp diagram, and let us do the configuration. I haven't done any configuration to any of the devices. Even the IP address also I haven't assigned. So let's do that. And so interface gig 0/1. I am inside router number R1. So gig 0/1 IP address I can give say IP address 111.255.255.0, and let me correct my subnet mask first. And in the site address, I am going to use loopback 1. Okay, so this will become say my 10.1.0.1/24. We can check IP in brief. So IP in brief, we can see that I have 2 IP addresses. One is for locator and one is for my site 1. Likewise, I can go to router number 2. Say host is R2, and one interface is going towards R1, one interface is going towards the core network, correct? Let me adjust this so you can see it properly. Now here interface gig 0/1 having IP address say 1.2, and one interface gig 0/2 having IP address say, we can take anything. For example, I'll take 10. So 10.1. say 23.2, because this is router number 2. So just for naming, no shut. Here I will initiate say BGP, router BGP, because this is inside the core network, and its neighbor will be 10.1.23.3. Remote AS I can take as 234. I'm going to advertise my network. What is my network? My network is, I have 2 network. One is say 1.1.1.0, and other connected network is say 23.0. Okay. But this is the network I'm not concerned about. Just for lab purpose we are doing it. Then we have our MSMR resolver or system. Let me give the name as host as say R3. Now let us see the interfaces. Let me go and check the interfaces. This should be gig01. Yeah. So interface gig0/1 having IP address of 23.3 and interface gig0/2 having IP address of, it is going from 3 to 4, so let's take this as a 34 network. Then I'll create one loopback, and that loopback IP I'm going to give say 5.1.1.1/32. Okay. Then router BGP 234. One of my neighbor is 10.1.23.2 with remote AS of 2, and one of my neighbor is going to be, so my other neighbor is going to be say 10.1.34.4 with remote AS I can take as 4. Then I can advertise the networks. One is 23.0, mask is 255.255.255.0, other network is say 34.0, 255.255.255.0, and one other network I have that is 5.1.1.1, that is my loopback address, and mask is 255.255.255.255, that is /32. Now I can check my interfaces. Here you can see interfaces are up and running. Now finally I go to router number 4 and let's do the configuration here as well. These interfaces are 0202. Let me adjust my screen. Yep. So this is my host number R4. Interface say gig0/2. IP address is 10.1.34.4. This is the inside 34 network. And then I have one other interface gig0/1, that is the IP address is say 2.1.1.2. 255.255.255.0, that is going towards the R5, that is the other side. Then I will do router BGP. For example, here we are taking autonomous system 4. My neighbor is 10.1.34.3 with remote AS of 234. So not network, my neighbor should be 10.1.34.3, remote AS is 234, and then I'll advertise the network. So one network is 34.0, mask I can take /24. As it is, one network is 2.1.1.0, mask is 255.255.255.0. Now finally we have to go and configure router number 5, that is towards the other side. So host is R5, interface is 0/1, IP address is 2, start with 2, so 2.1.1.1, 255.255.255.0, no shut, interface loopback 1 having IP address of the site that is 10.2. So I can give IP address at 10.2.0.1, 255.255.255.0. Alright, so we have done the basic configuration. Now we have to go and do the configuration for our Lisp. So I'll start from site number 1 router, that is router number 1, and then we'll move and do the configuration for MS, and then we'll go and do the configuration for the other site, that is the site number 2. Let us do the configuration for site number 1. Simply you can go and type router lisp. Okay. Once you are here, then you can type say endpoint table. Obviously your question mark will work. If you have VRF, you can give the VRF name. If it is not, then you can use default instance ID, say 0 I am using. Okay. Then I can go out from here and I can check database. Let us go inside that only and check what options we have. Okay. So here we have database table, and if I go to the Lisp mode, so here we have these locators and other options. Okay. So first of all, we'll go inside the default table and I'll take database mapping. What is the address I'm mapping for? So I'm going to map my site ID address, that is 10.110/24. What is my locator? Here you can see as well that you are mapping your endpoint ID prefix advertised to locators, max 5000 static prefixes. So this is the limit here. Alright. So I'm going to map this with 1111, that is my locator. Priority I can give say 10 for example. Weight I can give say 50. Correct. We'll do exit from here, and then this time I want to do the configuration, say IPv4. You can see here you have IPv4 for ETR and ITR. So if you are using IPv4 say ITR, then this is obviously your ingress tunnel router. So let me show you all those things. So if I go to ITR, you can see map resolver. What is the IP of the map resolver? That is 5111. Then IPv4 ITR. So this router is my ITR. Next time I can go to IPv4. Your Lisp interface is up now. This time I'll go to IPv4 say ETR, and if I check what option I have, obviously map server. Map server IP is the same. Now it will ask for key. Key is site1, that I will give in the map resolver as well. And then IPv4, this is the ETR. Okay. Then I'll create one IP route, default route, say towards my gateway. So let me do that quickly. 1112. Now I'm going to configure the other site router, same configuration I'm going to do. So let's do one more time. Router, Lisp, EID table, default instance ID is 0, database mapping, but this time the IP address is 10.200/24, and what is the locator IP? That is 2111. Priority I can give 10, and weight I can give say for example 50. I'll exit. I'll make this as a ITR and ETR. So ITR map resolver is 5111. IPv4 ITR, then IPv4 say ETR map server. What is that? 5111. Then I need to give the key as well. This is site number 2. Then IPv4 ETR. Exit. IP route, default route pointing towards the gateway. So let us give the gateway address as well. Gateway is say 2.1.1.2. That's it for these two sites. Now if you want to see this configuration, we'll check that. So here you can see that, okay, I am creating the endpoint ID table, default instance ID is 0. This instance ID we have already discussed that in case of virtualization we can change this. This is 24-bit ID. Then database mapping, my end host subnet mapped with the router locator with these priorities. Then I'm making this router as a ITR ETR. It is used in both encapsulation, decapsulation. In the other side also, this IP is 10.100 and then 1111, and we are using all those things. Correct. Now let me go to my resolver server, my map resolver server. We can check show IP BGP summary just to check my BGP, or you can use any internal routing protocol, is up. So here what I'll do, I'll go and enable the Lisp protocol. Now I want to give the site, because I have two sites, correct? So my site is site 1 and I want to give the key as well. So what is the authentication key I have? That is site 1, I think. Yeah, we have given authentication key as a site 1. Then what other option I have? Only few options we have. One is EID prefix. For this site, what is the prefix I have? That's it. Then I'll go and give site 2 as a key. First of all, I have to go inside site number 2. Then I'll give the key as 2. And then I can give the prefix. So 10 to 00. Let's check the configuration. Because I have given site 2. Okay, so this is correct. So in the map resolver, what I am doing, simply router list site 1. This is the prefix router 2. This is the key. It will authenticate with the control plane with these keys. These keys should match. So here is site 2. That's correct. Site 2 correct. And here also you should have site 1. That is also correct. So we are almost done with the configuration. Now if you want to verify, you can do show IP Lisp. So Lisp site, we'll verify the sites. Who last registered? They are showing never. They haven't registered. So let's stop here, and the verification task we'll do in the next section. Okay, so far these are the configurations that we have done, and our reference topology is this. So like that, I have created this topology over viral, and we have done all the configuration. The next section we'll do the verification, and we'll run some basic commands as well. Okay, so let me close here. Let us complete our verification. So far we have done the configuration. Let us check the configuration as well. Here you can see that configuration is router list, but this particular device here, that core router, core network, this particular device should be MS and MR. So what I have to add here, first of all, I have to add a few line here. It should be IPv4 map server. It should be IPv4 map resolver. Then I can check show Lisp site. My site should be registered here. So what I'll do here, I'll go to this point and I'll ping to the other side subnet, that is 10.2.0.1 with my loopback. source loop back 1. See, now it is pinging from this side to other side. Let me go here, check the registration. It should register here first of all. So with my loopback 0, it is pinging. If I check show IP route 10.20.1, it's not in subnet. That's correct. What I can do here, that let me go to router number 5 and show IP interface brief. That's correct. So I'll ping from R5 to R1 as well. Let's do that as well. Ping to this with my source loopback 1. I can see it is registering here. Okay, and before that I should start the packet capture ads as well. So what I'll do, I'll clear Lisp, and you can see we have all these options. So clear EID table, instance ID, locator, site, VRF. All these options we have, say site star, and from here also I'll come back here, clear site star. Now if I go here, clear site, let me see. Now site is already learned here. So show IP list. Before doing further verification, just we'll check this. It is able to resolve the map server, that's correct. Its locator is 211, that is okay. Okay. And if you want to check other options, so if you type Lisp and then question mark, you can see all EID, instance ID, etc. If you want to check more, like show IP Lisp, and then you have all these options. Now if you go to the map server or resolver, then here if you type show IP Lisp, here also you can see all those things. And if you go show Lisp and question mark, then also you can see all these options. So if I go, for example, to site, with related to site also I can see all those things. So here I have, because this is without any VRF site, without any virtualization site, so here we can see all these options plus no proxy reply, map, etc. Now what I want here, I simply want to clear everything, and then I want to start the debug so we can check the packet flow, packet captures like that. So clear Lisp, and then let me type correctly, clear Lisp, say a 0. Instance ID, I know that we have given 0 as an instance ID. Dynamic EID, and other I can give say site star. Other side also will do these things. Just try to clear everything before starting the packet capture so we can capture all the packets. Okay, so here also I can give dynamic EID, and in R1 let's do this debug Lisp, And do I have option all detail? Even if I check debug IP Lisp, so let's check that as well, debug IP. So I don't have that option. So debug Lisp. I can give control plane as well, and I have detail as well for the moment. And then I'll do debug IP packet as well, just to see all those things. Now from R5, I'm going to ping to R1. Let's do that and repeat for only one time. Come back here. Now here you can see that I have sent one packet. How it is? What is the source? What is the destination? So source destinations are the locator IDs. Source destinations, they are coming here actually. Now here you can see the actual source and the actual destination. So once the locators has been resolved, then we can see the actual source and destination. Okay, and where is the UDP headers? So let us see that as well. But everywhere you are seeing a Lisp like that. So it is resolving with respect to Lisp. Alright, so here it is not showing that where is the UDP packets. It should show UDP packets as well. What I'll do debug IP packet detail. Okay, and I'll send one more. I'll come back. Yeah, here you can see. Let me stop this so you can see it. Now here you can see that the same output we have, but in the detailed format, where we can see the source, destination, even you can see the mapping as well. Okay, so how the control plane is resolving these packets, it is showing here. TCP packets, you can see now, you can see this. Now here it is showing TCP 43, 42 TCP, just to have the say three-way handshaking. And if I scroll up, now you can understand that we have referred all these say internal headers, external header, UDP packets or UDP headers, plus the Lisp headers. So all these things you can see here. Okay, so pause your video, have a look. Let me scroll down. Make your notes. Okay. All right. So this is the verification and testing we have. So what testing we have done, that if you are pinging to the destination, you do not have that destination in your routing table. So how it is resolving? It is resolving via the Lisp. So you don't need the host table and the topology table inside all the devices. Although the topology table you are resolving, you are querying, you are resolving, and then you are going to the destination. That is the overall idea of the Lisp infrastructure. Okay, so I'm going to close here, and in the next section we will learn more about the configuration, say configuration with respect to virtualization. In this section I will explain you that how you can do the configuration of network virtualization with help of Lisp. Now here you can see that in this particular topology I have shared mode virtualization. Means my devices, they are connecting with the core network with two VRF1, VRF2, and obviously these VRF traffic will be separated. How it will be? So here you can see that VRF one means site 1 configuration where I have VRF definition VRF1 address family IPv4 and then also VRF2. So I have two VRF, and in these two VRFs the site addresses we have like 20.1 and 30.1. Now in my lab, in our lab, what we'll do that instead of these interfaces and the encapsulation .1 queue, we'll use loopback. Okay, so I will use a loopback 201, loopback 301, and then inside that VRF, I will assign these IP addresses and I will do this configuration. Then Lisp part. Now Lisp part, what we have, because we are creating VRF, so we have to give the instance ID. So instance ID 1 is mapped with VRF1, instance ID 2 is mapped with VRF2, like that. And the rest of the configuration you can see they are the same. Only we have to map the instance ID with the VRF and then we have to do the database mapping. Likewise, the site 2 also same type of configuration, but here the subnet are 20.2 and 30.2. No brainer, same thing. Then finally the configuration in the MSMR router. In MSMR router, the same thing again we'll do, but here we have to add two sites. One is VRF site VRF1, other is VRF site say VRF2. The rest of the configurations are same. So here we are mapping say 20. Now this is the other site configuration. Let me go next. So here you can see we have this configuration MSMR where I am mapping site 1 with two prefixes or two subnets of the site with instance ID 1 and 2. In site 2 also we have 2232 with instance ID 1 and 2. The rest of the configuration is as it is that we have done so far. Now in the same topology I'm going to do this, so let me go and log to our lab. Alright, we are in our lab and here what change I am going to do. So I will change this as a 20 network. So I have 20.1 inside one VRF. So this may be my say VRF1 network, correct? And then I have some other network as well, say 30.1 0.0/24 that will be inside VRF2 in the same site, correct? Same, I'll copy paste this side. Let me go and copy paste this side. Let me delete the old one. And here I'll make this as a 20.2 and I'll make this topology as 30.2. So this is my site 1 and site 2 because we have VRF1 and VRF2. Rest the core network is the same. Only thing that we are going to do is the change in the configuration. So now if I go inside router number 1 and if we check our show run and then section Lisp, this is the old configuration. I need to edit this. Before that, I'll create one loopback, say 201. I'll assign IP address something 20.1, 0.1, 255.255.255.0. This is the IP address I assigned here. But once you assign the VRF, again you have to rewrite the address. So better, first of all, create VRF. So we'll do that. Even we can simply create VRF or we can use VRF definition. VRF definition say this is VRF1. Address family is IPv4. We can leave it as IPv4, that's it. Exit. I'll define one more VRF here, VRF2. Address family IPv4. Exit. Now I can go to loopback interface, say 201 that I created, and here I can give, say, IP VRF forwarding. What is that? VRF1. If you want to check your VRF, you can check like this. Use VRF forward command for this. So VRF forward and then VRF1. Now you need to give the IP address here because you have assigned inside the VRF. So I have this IP address I'll assign here. Likewise, I'll create one other loopback, say 301. So interface loopback 301. This time this is under VRF2, and then I'll assign IP address at 20, not 20, 30, 30.1.0.1, 255.255.255.0. Okay. Now because I have this loopback created here, so I'll take this advantage and I'll copy and paste this configuration to other side. So other side also I need to create the VRF. Let me go to other side and do that configuration. Let me copy up to this portion. Yeah, here. Site number 2. So here also I need to create VRF definition, say VRF1, address family IPv4, exit. VRF definition VRF2, address family IPv4, exit. Then I need to create one loopback, but 20.2.0.1. Correct. I'll create one more loopback that will be 301, and this should be VRF2, and then the IP address here we have, so this should be under VRF2. So let me show you this, and then the IP address is, we have, let me assign 30.2.0.1. Okay, so far till the IP address is okay. Even the IP route is also okay because my egress interface IP route is correct. Okay, so let us check here as well. This is from the old configuration. Now we need to edit our configuration. So whatever configuration we have done with respect to Lisp, we need to edit this. So instead of instance ID 0, I have to give 1 and 2 like that. First of all, we'll go inside Lisp and the EID table. I need to change this. So EID table question mark VRF is there by default. So VRF name, I can give say VRF1. Instance ID I can give say 1. Correct. Now here I can do the database mapping. This time I have 20.100/24. It is mapping to 1111, and the priority is say 10, weight is say for example 50. Exit. Now here I have other instance ID as well, say instance ID 2 and VRF is also 2. Database mapping this time is 30.1.00. 24, it is again mapping to the same IP because egress interface IP or router locator IP is the same only. Okay. Rest of the configuration will be the same that we have done so far. So rest of the configuration means ITR and ETR configuration. So ITR map resolver, correct. ETR map resolver, the key is site1, that is correct. So what we have done here, we have added the instance ID here like this. And now the same configuration I have to do in the other site as well. So I can copy at least up to here. Even I can copy, yeah, I can copy at least up to here because other side everything is different, correct? So we'll go here first. We'll check the configuration, old configuration that we have done in the last lab section Lisp. All right, so I'll go to router Lisp, and even I can copy paste. Otherwise, first of all, I have to go inside VRF. So instead of default, I can go inside say VRF1 instance ID. I can give say 1. This time our database mapping is 20.2 because other side is for 20.1. 24, the priorities, the RLOcator is this, and the priority 10, weight I can give 50. I can press up arrow to change the VRF and the instance ID, correct? And then even the database mapping IP will be 30. We can verify. Section Lisp. The old configuration, whatever related to ITR and ETR will be the same. So instead of list, it needs to use Lisp. Okay, so here you can see the instance ID to address mapping, instance ID to address mapping, the rest configurations are the same, 100% correct. Okay, then finally we have to go to the MSMR router and we need to map those VRFs here as well, means we need to give the subnets. So what is the old configuration we have? This is the old configuration. Now here, let me show you that what configuration we have. I have to go inside, I'll go inside site1, and then obviously authentication key will be site1 as it is, but the EID prefixes. Now we have two EID prefix. So if I type EID prefix question mark instance ID, you can see 1. Now I can give the prefix. So prefix is what from site1 I have 20.0.0. That is obviously for site1. I think that's it. This is for site1. And what is the other instance ID we have? 2 30.100/24. Then I'll exit. I'll go to site number 2, and here also I have to give the authentication key as site2. That is already there. Before doing anything, let's verify it, how much we have configured. So site1 instance ID 1 2, that's correct. Site2 authentication key is correct. Now inside site number 2 I have to give the instance ID as 1 and the EID prefix is what? So that is 20.200/24, and then I have 30.2. Let's verify this configuration. So I'll go to the Lisp. Correct, and then we have the map resolver. So this is the whole configuration we have here. Now let us just stop here, and in the next section we'll do the verification. Let us do the verification. Let me go to the devices and we'll see the configuration first, then we'll do the verification. What is that brief? Let's see that what loopback addresses we have. Now here you can see that loopback Lisp 0.1, 0.2. It is there for 201 and 301. In the site 2 also we can verify that. So here also you can see. Now what I'll do, I'll ping to the VRF, say site 1, and what's the destination I have? .2, my source, so VRF. Okay, so my VRF name is not site 1, that is VRF1, and the IP address source is 20.1.0.1. Here I'll do this thing, I'll debug Lisp. I'll do detail. Alright, so we'll send the packet. Repeat 2 times. We'll come here. I'll do debug IP packet detail. Alright. So VRF is unsuccessful. Let me check one more time that if I am able to ping to 5111. Let me check VRF1. Alright, so we'll check show IP route. Let's see. So my route is this default route I have, and show IP interface brief. Show run interface loopback 201. You can see that we have some problem. We're not able to reach from one side to other side. So we'll see that where is the problem. So here I can see that when I use this Lisp 0, it is coming here as a connected, but my loopback 201 and 202 as a Lisp sub interfaces, they are not coming in the routing. So for that I need to check show IP route VRF1 should come here. VRF2, it should come here. That's correct only. Let me go to router number 5 and here you can see that we are getting lots of messages. Here you can see the registration messages as well. Routing succeed. So if I go to R3, if I go and check, so Lisp site, you can see all the registration is happening correctly here for all the endpoints. Let me go and check this, ping one more time. Still not able to reach, but I'm able to register here. If I do undebug all, let us scroll up and verify. So here you can see on the top that what is the source, what is the destination, default route, forwarding, valid packets. So validation is successful. It's valid. TCP packets are valid. So it is showing that the validation is successful. Let me do one more thing here. Let me ping from here. My VRF is VRF1 20.1.0.1. Source is loopback 201. It's pinging. What source I have used? Oh. So it should be 20.2. And give me some more counts. Alright, so from here it is not, but from here it is reaching. Wow. Now maybe some wrong IP I'm using. Let me re-verify this. Loopback 201. And instead of that, if I use simply loopback 201, the IP is wrong. The IP should be 20.2.0.1. Okay, so you should give correct IP, huh? And then I can check Lisp router ID. I want this instance ID 1 because we have two instance ID, correct? Instance ID 1 and instance ID 2 we have. It will show this thing here. Okay, so we can check the ID registration 1 and we can check the ID registration 2, no problem. In router number 1, what I can do, I can check Lisp and then instance ID 1, like this. Okay, and if we check show IP route, say VRF site, VRF is what? VRF1, correct? If I am giving site 1, that will be the wrong. And then if I check the route 20.2.0.1, it should not be in the table. But if you ping, you are able to go and ping, no problem, because registration is 100% correct. Likewise, if you go and ping, this should also work. And then if you debug, your debug packet will also work. So first of all, they're taking some time just to do the registration. Once they do the registration, then they will ping easily. So 30.101 and 30.202. Okay, but you can see here it is working correctly, and the same configuration we have both the sides. Okay, so we are very much good here up to this point with the verification. We have done the verification. We are doing the testing. In testing, we should give VRF2 to work, correct? So you need to give the correct type, you need to give the correct VRF, and then it will work. Correct interfaces. Everything should be correct. Okay, so alright, so we can stop here, and next section I will summarize all these things. So far we have studied about Lisp, different things inside Lisp, different terminologies inside Lisp. All these things we have studied so far, and then we have done lab related to instance ID 0, 1 and 2, means without virtualization and with virtualization. In this section, I am going to show you some of the features that been introduced in Catalyst platform. If you are thinking Lisp with respect to DNA, then you can leave this. But suppose in your infrastructure, if you have Catalyst switch and what type of features you have in the Catalyst switch, for that you can refer this particular section. Now, deploying Lisp on a distributed layer switch. The Lisp can be deployed in a standalone chassis, single or dual supervisor, or in VSS mode. What you have to do, you can go to the interface and you can enable platform Lisp enable, and that will be enabled. Rest all those features and theory we know that where you have to assign the router locator IPs and how it will work. Those things we know. So one feature that you can enable Lisp over SVI over Ether channel, that is one feature. The other thing that whenever you are doing virtualization with respect to Lisp, then that will run under shared mode virtualization, and you have to assign the instance ID. Now inside supervisor engine, you can see here I can execute this command router context vrf vrf1, and then I can ping from source to destination. Then I do not have to give the ping vrf name and then the other strings. You can go inside the VRF and from there you can do the testing. Okay, so that is the other thing. The other important enhancement we have that we can do the flexible net flow with respect to Lisp, and here it's the sample configuration for you that you can refer it. Yeah, but you can monitor with respect to net flow the in-cap and decap packets. So here you can see that side 2 branch distributed catalyst, and I have the net flow cache on ingress and egress interfaces. We are using the net flow to monitor the flow before and after Lisp encapsulation. So this feature is there. Apart from that, we can do ingress egress with respect to data plane. We can do ingress egress with respect to control packets as well. Okay, so this example you can see here that I have my MS MR devices and we are viewing the net flow cache on the control packets. That option is also there. Okay, so what we have covered so far, that we have some features. So features like we can enable Lisp over SVI Ether channel, over VRFs. We can go inside VRF and again we can do basic troubleshooting, testing. We can enable NetFlow, and finally it is supporting under NAM module. So we can do some packet captures with help of Wireshark. We can see those captures. NAM 3 version 6.0 support Lisp packet analysis. Alright, finally you can refer the line card as well. So Lisp and instant access. Whenever you are using fix module, at that time you can check that as well. And finally we reach to the summary. So what we covered so far, that Lisp is a routing architecture, not a feature. Lisp enable IP address portability. We have seen that we can decouple, or we can separate the host route and the topology route. Lisp enable pull versus push routing using mappings. Lisp is address family agnostic. This also we have seen in the example. Lisp has inherent advantage in multi-homing and virtualization. This also we have seen in the example. Even for virtualization we have done lab. Lisp is the open standard. If you want to refer the RFCs, these are the RFCs for your reference. Okay, if you want more detail on this, you can go and check the RFCs. Okay then, thank you then.